In today's video, we're going to cover the different key features of quadratics. This time, we're going to be given an equation versus a graph. Now, graphs, in my opinion, are the absolute easiest way to find all of the key features. So luckily, you can simply change an equation to a graph just by using a graphing calculator or Desmos. To do this, you go to Desmos and you add an equation, and then you type exactly what you're given. Do I need to put in the parentheses? Absolutely. If you are given parentheses, you use parentheses. If you're not given parentheses, you don't use them. Do not do anything extra. Your goal is to make what you type in look exactly like what you're given. Now, again, the key features have not changed. I personally start with domain because it's the easiest. It is all real numbers all the time unless you are talking about a word problem for the sake of quadratics. Next, I like to use the vertex because it helps answer so much information about the rest of the key features. Now, the vertex, if you remember, is where the graph turns, or it's the top or the bottom. Okay, again, if you just remember turning point, that's probably the easiest way to remember where vertex is. So if I look at the graph, I can try and zoom in to see if I can find it. But when I zoom in, I see less of the graph. So now I'm going to zoom out. And when I zoom out, I can see it down here at the bottom. Now, you could do one or two things. You could try and guess what it is, or you could be more accurate and actually know what it is. So if you see, currently I have 4 gray dots on my graph. Now I have none. I have 4 gray dots. I have none. Desmos is so cool because if you are pretending like you're going to keep on editing the equation, or if you have your cursor blinking in or where you're typing the equation, it'll actually list every key feature for you besides in behavior. You just have to know them. Okay, so I know the vertex for this particular equation is -2, -25. I know my axis of symmetry is the x value of the vertex, and it's in the form x equals. Max min, I know is the y value of the vertex. And it is -25, and again, it's in the same form, y equals -25. My roots for zeros are probably the next easiest, right? This is just x-intercepts, so where the graph crosses the x-axis. Again, and I only want the x values. So -7 and 3. I, again, personally like in behavior over range because in behavior is always in the following form. X goes to -infinity, y goes somewhere. X goes to positive infinity. Okay, y also goes somewhere. Now again, my way of around this is that as x goes to the -infinity is the leftmost piece of your graph, and then as x goes to positive infinity, that's the furthest most right piece of your graph. So I go to the left piece, or the leftmost piece, so it's up here at the top. Well, it's pointing up. Now I want to make sure it keeps on going, and I zoom out twice, maybe 3 times, and I see it does. So this lets me know it's getting bigger and bigger and bigger and bigger, eventually going to positive infinity. I use that same approach for the right side. So I find the rightmost piece of the graph. It's pointing up. I've already zoomed out. So it's also going to positive infinity. Now the only thing that's left for me to do is my range. And again, for a range, you want to pick the value that the graph starts with. Okay, so another little tip is that the range will always be a part of your vertex. Min is the smallest value. Well, your smallest is your starting. So negative 25. And then it goes to your end behavior value. So positive infinity. If this was a max, then max is the biggest. So the biggest would be on the right. So again, this is my max value. Over here on the left is my min value. So use your max min to help you out with your range.